Hello everyone. I'm going to talk about a 6.1 antiderivatives. This is the video for a lecture. So I'm planning to do a lecture as the one separate video, and the other one will be problem solving. For 6.1 antiderivative. So we have to talk about the derivatives. Let me review what we did before. For example, if you have a function f of x that is equal to x to the third plus 3, then we have been practicing for the several days that the derivative of that is equal to 3x squared and the derivative of 3 because it's constant and which is going to be 0. Now, this is a taking derivative. Antiderivative is the backward calculation. So if you are having a derivative, how would you go back up to find the original function? Then what we do is if you integrate f of x dx, if you integrate the derivative or if you integrate a function, what is the original function that it's going to give you? So based on, according to our example, is going to be if you integrate 3x squared dx, then instead of the power goes down by 1, bring the number to the front, you will actually stack this number or increase the power by 1. And you will actually divide it by 3 to balance it out. Therefore, this is truly the backward calculation. However, if you notice that this is the 3, regardless of what number you're getting, if it's 3 or 4 or whatever the number is, this is going to be the derivative of 3x squared because the derivative of a constant number is going to be 0. Therefore, as in the original function, you could add up at any constant value such that your derivative is going to be 3x squared. So I'm putting a C because 3x to the third plus 2 or 3 or 4 or whatever that number is, you're going to get that. Now this is called indefinite integral. Now another name for this will be antiderivative is integral. So integral and the derivative, they're almost like canceling each other types of calculation. So this is the fundamental rules of how would you do an integral, but this is more like the power rule as one example. I'm going to get through several other types of calculations. This is the regular polynomial. We're going to have the exponential, just parallel with the types of calculation we did with the derivatives. Now, before I'm moving to there, let me go through some of the some of the theorems. No. So if I give you the general rule, this is called the rules of integration. Rules of integration. And the first rule I want to go in a more generalized format is the power rule. That is just in the formula-wise how to describe the example I just did. That is the integral of x to the power n dx. That's going to give you x to the power of n plus 1. Let me rewrite this. That's going to give you x to the power of n plus 1. And you have a balance factor 1 n plus 1. So that when you take a derivative for this, bring to the front, this coefficient canceled, and this the exponential portion will becomes n plus 1 minus 1 becomes xn. However, you're going to have a plus c. All of this indefinite integral you're going to get, which means you don't have the boundary, you're not trying to evaluate, you just integrate a function, and you want to have a plus c because whenever you have a plus c, when you do backward, this plus c's derivative is 0, and I'm going to cancel that out. Then there's some other rules. This is called a power rule. And the second rule is constant times the function rule. Which means if you are integrate of k with some kind of function, then what you're getting is this number. You can pull it out, then integrate in the end. This is very similar to the derivative when you have a constant number multiply a function, then taking derivative, you can always leave that constant in the outside, then take the derivative and then multiply it back in. And that's similar to that. So when you have a constant, you really don't have to worry about it, just multiply it to the end. And the third rule will be sum and or difference rule. Sum or difference rule. Which means if you're going to integral or doing this antiderivative to two functions and they are additive or multiplicative, or one add to another, integral f of x add to each other or subtract one to the other and respect to x, then that is the same thing as you're doing them separately. You're doing dx plus or minus integral g of x dx. And that's the third rule. And now I'm getting a little more specific, similar to the power rule. Number 4, I'm going to do the indefinite integral of exponential function. It's called indefinite integral of an exponential function, which means we're integrating a polynomial. Now, what if this is e to the x dx? Well, as similarly to what we did with derivative, the derivative of e of x will give you e of x. So integral of e of x will give you e of x as well. But because it is indefinite, you want to have a plus a c in the end. Then I'm going to give you another one is indefinite integral of a function such as that 1 over x. So what is the integral of 1 over x dx? Well, we do know natural log of x is the derivative of 1 over x. Therefore, when you integrate that, it will go back to natural log of x. And because it's indefinite, you want to have a plus c in there. Now, there is going to be, that's actually pretty much the common things we're having as 1 over x, e to the x, x to the n. That will be the portion or the type of formula you want to memorize. Then the rest of them is really when you have a more complicated case, have a k multiply it, or have multiple functions add to each other or subtract to each other, how would you do the calculation? In the next video, I'm going to go through some of the questions and solve all those questions as examples. So hopefully it will enhance your understanding of what is antiderivative.